Welcome to this explainer. Look, if you've ever felt the growing pains of a Python project where the code just gets too long, messy, or fragile, I found some incredible strategies today that separate basic beginner scripts from truly robust professional-grade programs. Because let's be honest, when everything lives in one massive file, you're just waiting for a disaster. You need structure, you need efficiency, and you need a solid safety net. So let's look at exactly how we can build those.
Here is our roadmap for today. We're going to cover modules and packages, Python multithreading, Python exception handling, and finally, your practical tasks and outcomes.
All right, let's jump right into section 1, modules and packages. Basically, organizing your coding toolbox.
So think of a module like a highly specific tool in that toolbox. You create it just once, right? And then you just import objects from it whenever you need them. Instead of agonizingly copy-pasting the exact same block of code 50 times across 50 different files, you write that module once. It's a total game changer for code reusability. It keeps your main script super clean and focused, while all the heavy lifting just quietly happens behind the scenes.
And what's really amazing here is that Python actually comes packed with powerful built-in tools right out of the box, like NumPy and SciPy. You don't even have to write these yourself. For your learning objectives, you're going to identify and use functions from these specific modules to do things like perform complex matrix operations and solve algebraic equations. Just by importing NumPy and SciPy, you literally supercharge your program with advanced math capabilities that would otherwise take, thousands of lines of code to build from scratch.
Now, if modules are the individual tools, a package is the entire toolbox. It's a structured directory that lets you group related modules together. As your projects scale up, you're going to have dozens of modules floating around. A package keeps them perfectly organized. This is how you achieve true professional-level code modularity. You're basically building your own custom libraries that you can just drop into any future project, saving yourself countless hours of work.
Moving on to section 2, Python multithreading, or how to do more things at once.
So instead of waiting for one task to painfully finish before starting the next one, multithreading actually lets your program juggle them concurrently. Imagine trying to download a file, process a massive dataset, and update a user interface all in a single linear sequence. It'd be unbearably slow, right? Multithreading completely changes the game by creating separate threads for these operations. It lets your Python program juggle multiple functions at the exact same time, making your apps way faster and so much more responsive.
Okay, section 3, Python exception handling. We are building the ultimate safety net.
Because, look, there's a massive difference between mistakes that stop your code from even starting versus runtime errors that crash your program mid-flight. Compile time errors, those are usually just typos or bad syntax. Python catches them early and just flat-out refuses to run. But runtime errors, those are sneaky. They happen while the code is actively executing. Maybe a user types a letter instead of a number, or a crucial file suddenly goes missing. Without a safety net, a runtime error is going to instantly crash your entire application.
To safely catch these runtime exceptions, we use a very specific flow. First, you literally tell Python to try executing a block of code. If a runtime error pops up, instead of crashing and burning, the program gracefully jumps down to your except block. That's where you handle the issue, maybe by showing a friendly warning message to the user. Finally, you can use raise or assert statements to intentionally trigger exceptions when specific conditions aren't met. It gives you total, absolute control over the flow of your program.
You're going to need to write blocks specifically to handle common built-in exceptions like name error, value error, and type error. I mean, we've all tried to add text to a number and watched our script blow up, right? Catching these specific errors makes your program practically bulletproof. A name error happens if you try to use a variable you haven't defined yet, while a type error catches that text and number mismatch. And for those truly specialized problems, you'll actually learn to create user-defined exceptions tailored exactly to your unique app.
Which brings us to section 4, practical tasks and outcomes. This is your programming blueprint. Let's take a look at how we're going to map out exactly how you can prove these skills through hands-on assignments.
This table right here is your exact path to success. For task 10, you're going to tackle learning outcomes 3.3 and 3.4 by creating your own reusable packages. Then in task 11, you get to bring multithreading to life by running functions concurrently. Task 12 has you building that try except safety net to conquer learning outcome 3.1. And finally, you'll cap the whole thing off by utilizing NumPy for matrix operations to hit that final objective 3.2.
But beyond these structured tasks, your syllabus also includes a self-learning objective. to independently study media-related modules in Python. And honestly, this is where you really get to stretch your wings. Imagine writing just a handful of lines of code to completely automate video editing or image processing. That's the kind of power you unlock when you understand how to utilize these modules. You can explore libraries designed for complex audio manipulation or graphics and apply the exact same modular principles you've just mastered.
So, you've built the foundation with packages, threading, and exception handling. The safety net is there and the tools are ready to go. The only question left is, how will you use Python media modules in your next project to build something extraordinary?